Hello Year 10. Today we're going to be looking at index laws. Now if you haven't done one of these lessons before, what's going to happen is I'm going to share with you a lesson on screen which you'll be able to see, and I'm going to talk over it. Every now and then there'll be questions to answer, and you'll be able to pause the video to answer those questions, or I'll provide you with an alternative where you can go and find more of your own questions. Okay, anyway, let's begin. Okay, so you should be able to see the lesson on screen now, and you should still be able to see me in the corner of the screen, and you should also be able to hear me. Okay, so like I said, we are going to be looking at index laws. Now, index laws are, or indices, provide us with a convenient way of dealing with values, both when those values are numbers or when they're algebra. Indices is simply the plural of index, which is where index laws comes from. And an index is often referred to as a power. So on screen now, let's reawaken some old knowledge. This is stuff that we should already be able to do. So what I want us to do is to answer these questions. And you'll have to pause the video so you can answer the questions, and then the answers will come up. So we should already know that 5 times 5 times 5 is 5 to the power of 3, or 5 cubed. Similarly, 3 times 3 times 3 times 3 is 3 to the power of 4. Okay, it shouldn't bother us when we switch to using algebra terms. So have a quick go now, pause your video, and then the answers will come up. Okay, here's the answers that you should have got. As you can see down here, the algebra didn't bother us. We still wrote it with the power. All we looked at was how many times have we multiplied that value by, and that gives us our power. However, something we need to take into account is we can only simplify if the base numbers are the same, or the base values are the same. So we've just had 5 times 5 times 5, which we know is 5 cubed. Here, the base value is 5. It doesn't change, it's the same, so we can simplify it. Here, when we switch to algebra, we've got q times q times q times q times q. The base value is always q. We've multiplied it by itself 5 times, so we end up with q to the power of 5. So the base value here is q. The base value up here was 5. So long as they're the same, we can simplify, and we know that 5 is the index, or the power. But when we've got different base values, we have to deal with them separately. So here we have to deal with the t's, so we'll end up with t squared, and we've also got to multiply by a p. We can't simplify them all together because their base values are different. So we'll end up with t squared times p, which we know in algebra we write without the multiply, so we end up with t squared p. So just be careful, check the base values are the same, and only simplify base values that are the same. So let's make a start on our actual index laws. The first law we've got is the multiplication law. So the general rule up here, if you have a look, tells us that what we're actually ending up doing is adding the two powers together. So when we're multiplying, we check the base value, and then we simply add the powers together. Here the base value is 2, so we can simplify. 6 plus 4 gives us 6, so we end up with a base value of 2 plus 4, 6 plus 4 gives us 10, so we end up with 2 to the power of 10. Here, check the base value, which is once again 2, so we can simplify. But just be careful here, it looks like there's no power. There is in fact a power, it's to the power of 1. That is a mistake you may well make, forgetting that that is to the power of 1. So here we've got to do 4 plus 1, which will give us 5. Our base value is 2, so 2 to the power of 5. Here we switch to algebra. It doesn't bother us at all. We just follow the same rule. The base value is p, and we add the powers, giving us p to the power of 12. So what we have to remember is when we're multiplying, we add the powers. Okay, let's switch to division. You'll see the general rule up here. When we're dividing, we subtract the powers, which kind of makes sense, really, doesn't it? Once again, we check the base value, it's 2. Now we're going to subtract the powers. 6 take away 4 gives us 2. So we're going to end up with 2 to the power of 2, or 2 squared. Here, check the base value, it's 2. Now subtract the powers. Be careful, this is to the power of 1. So 5 minus 1 is going to give us to the power of 4, or 2 to the power of 4. Here, we've switched to algebra, but it doesn't matter. We are still going to subtract. 5 minus, hang on a minute, 5 minus 7, that's going to give us minus 2, which is absolutely fine. Negative powers are okay. That is another mistake you might make. You mightn't like the fact that you're going to end up with a negative power. Negative powers are okay. We'll deal with them in the future. What we have to remember is when we're dividing, we subtract the powers. Okay, let's have a go. Here are your questions. The answers are going to come up shortly, so pause the video to answer them. Okay, here come your answers. So here we had to add the powers. Here we had to add the powers, remembering that was a power of 1. Here we had to subtract the powers, even though that should have been to the power of 3. So little mistake there, don't worry about it, we've spotted it. Here we were adding the powers. Here we were adding the powers, remembering that our base value was a y. Here we were subtracting the powers. And here we were also subtracting the powers, even though we ended up with a negative value. It doesn't matter. Okay. So let's up it a level. Here we're dealing with something called a coefficient. Now, the coefficient is the number in front of the algebra value. And it simply tells us how many of those algebra values we've got. Here, we're dealing with a to the power of 3, and we've got 2 lots of them. Here, we're dealing with a to the power of 4, and we've got 3 lots of them. Because of that, we've got to deal with the coefficients. And we're simply going to do what it tells us. Here, it tells us we're multiplying, so we're going to multiply them together. So we're going to multiply our coefficients, and then we're going to apply the algebra rule where we're going to add the powers. So here we do 2 times 3, and then we do a cubed times a to the power of 4, which means we add the powers. And we end up with 6a to the power of 7. 2 times 3 gives us the 6, and then we add the powers for the a value. Over down here, we're dividing. So we're just going to do what it tells us. We've got to deal with the coefficients. 8 divided by 4 gives us 2. And then we're going to subtract the powers. So we're going to have to do 6 minus 4. So 8 divided by 4. And we've got to do 6 minus 4 over here. And our base value will be a. So we'll end up with 2a to the power of 2, or 2a squared. Okay. Once again, have a go at this question. Pause the video, the answers will follow shortly. Okay, so here we had to deal with the coefficients. There's only one on this side. On this side, it's a 1. So 5 times 1 gives us 5. Now we deal with the x's, add the powers, x to the power of 6. Now we deal with the y's, not forgetting that's to the power of 1. 3 plus 1 gives us 4, so y to the power of 4. Over here, we've got to deal with the coefficients. 7 times 3 gives us 21. Now let's deal with the w's. To the power of 1 over here, to the power of 3 over here, gives us to the power of 4. Now let's deal with the x's. To the power of 2 over here, to the power of 1 over here, which gives us to the power of 3. Okay. Sometimes we also have to complete more than one step. Now you'll see here, we've got a multiply and a big divide. We've got to deal with them one at a time. So we're going to follow the rules one at a time. Let's just check our base values are the same. They are. They're all 2s. So at the top, we've got some powers to add, and then we've got some powers to subtract at the bottom. So if we do the top first, we're going to add the powers, which gives us 2 to the power of 10 divided by 2 to the power of 3. Which means we can now simply subtract our powers, and we end up with 2 to the power of 7. So take it one step at a time, do the multiply first, do the divide second. So if I go another one. So over here, the base values are the same, they're all 3s, but we've got to add the powers at the top, and then we've got to subtract the powers underneath. So if we add the powers at the top, we end up with 3 to the power of 12, and then we've got to divide by 3 to the power of 4, which means we're going to subtract the powers, which leaves us with 3 to the power of 8. So sometimes you have to complete more than one step. Just follow the rules. Follow the multiply rule by adding the powers first, then follow the divide rule by subtracting the powers next. Okay, have a go. Once again, pause the video. Answers will follow. Okay, so in this one, we had to do a divide the coefficients, which gave us the 9. Then we had to subtract the powers for the E's and subtract the powers for the F's because we were dividing. This one, we had to multiply the coefficients and then add the powers. And then we had to subtract the powers, leaving us with this answer. This one, there were no coefficients to deal with. We just had to add the powers, not forgetting that this was a power of 1. And then we had some powers to subtract in step 2. Down here, we had to multiply the coefficients. Then we had to add the powers, which at the top gave us 3 to the power of 5. And then we subtracted to the power of 4, which left us with to the power of 1, which we didn't need to write. But it's okay if you wrote to the power of 1, although we didn't need to. And then finally up here, we had coefficients at the top and the bottom. So we had to do 6 times 4 and 2 times 3. So 6 times 4 gave us 24. 2 times 3 gave us 6. We then had to divide them, which is where the 4 came from. We then had the powers to add up here, the powers to add up here, not forgetting that's to the power of 1. We then had to do a subtract, which is where to the r to the power of 4 came from. Okay, the final law is what we call the power law. And you can see what's happening over here is when we have got brackets involved, we are actually multiplying the powers. So if you see brackets, we multiply the powers. So simply, 6 times 2 gives us our power. Our base value is 2, so 2 to the power of 6 times 2 to the power of 6 gives us 2 to the power of 12. 6 times 2, you'll see 6 times 2 gives us our power. And what we've actually done here is 2 to the power of 6 times 2 to the power of 6. Here, we've got to do 3 to the power of 5 times 3 to the power of 5 times 3 to the power of 5, because that's how many times it's telling us to multiply. But what we've actually done quickly is multiplied the powers together. So we end up with 3 to the power of 15. So what we need to remember is when there are brackets, we multiply the powers. Okay, have a go, pause the video, answers will follow shortly. Okay, here come our answers. So here, multiply the powers. Here, multiply, well, we had to work out what we've multiplied 4 by to get to 12. Here, we've had to work out what we've multiplied 5 by to get to 15. Here, we've had to work out what we've multiplied 3 by to get to 12. Here, we've had to work out what we multiplied 5 by to get to 20. And here, we've had to work out what we've multiplied 5 by. Sorry, I beg your pardon. Here, we've had to work out what the base value is. So the base value stays as a 3. Okay, then we switch to algebra, but it doesn't bother us. Just multiply the powers. Down here, the most difficult one, what we had to do is deal with the coefficient. So here we had 2 to the power of 4 to deal with in the first instance. 2 to the power of 4 is 32. And then we had to multiply the powers. Down here, once again, we had to deal with the coefficient, which this time is 2 to the power of 5, which is 64. And then we had to multiply x to the power of 5 and y to the power of 3 times power of 5, which is where the power of 15 comes from. Don't worry if you didn't get them. They were designed to be challenging. Okay, so that's the end of our lesson. What I'd like you to do is, if you want, you can take a photograph of your answers and you can send them to me at this address. I'd like you to try and give me some evidence of how you've completed your work. If you've got any questions, you can contact me directly on this email and I'll do my best to answer them. Or you can attend our weekly drop-in sessions, which I think are going to be Fridays. There'll be more information to follow. If you want to do any more questions, you can log on to Corbett Maths website and look up indices, laws of, and there's loads of questions for you to try. Okay, I'll see you next time.